Ofer Maor is our speaker today. He's the CTO from Koshin. He's going to talk about the I is greater than S plus D, interactive AppSec testing beyond SAST and DAST. Ofer Maor.
Thanks all for coming. I know there are a lot of good lectures to choose from, so we thank you for choosing my lecture. So, what we'll do today, I'll talk about IAST, which is a new technology for doing application security testing. I'll start by explaining a little bit what it is, and then a little bit why we want to do it. And we'll talk a little bit about the shortcomings that we've seen with other technologies, DAST, SAST, and their combination, and then try to get into the details of why IAST is providing us some more value. I'll give a lot of examples, technical examples, in the second half of the lecture. Not too difficult to get, but a little bit technical. And we'll talk a little bit about IAST architecture, how it works, how it's deployed, and so on. We're not a huge crowd, so I don't want to wait just until the end with questions. So if something's bothering you, if you want to understand, if you don't like something I'm saying, if you want to argue, that's all fine, within reason. So just raise your hand and we'll try to get that in the middle of the talk. For those of you who don't know me, I've been doing information application security for 17 years now. I've been in this field for a long time from all the different aspects of it. I've been a consultant, I've been a pen tester. I used to work for a WAF vendor, and now I have my own company for application security testing. So a lot of different sides of this industry. I've seen a lot of customers with a lot of problems in their code. So I think I can bring some value. I'm also part of OWASP from day one. And I'm the chairman of OWASP Israel and part of the OWASP Global Membership Committee. Just 2 words about my company. Koshin, we do Seeker, which is a new generation of application security testing. I'll make it very clear what we do is IAST, but I'm not going to talk about our product, even though some things may overlap. I'm going to talk just about the technology. If you want to hear more about the company or whatever, just come to me after the presentation. We don't like to damage the neutrality of talks in OS. So, what is IAST? IAST, Interactive Application Security Testing. It's a term used by Gartner, but we adopted it. With Gartner also named DAST and SAST originally. And under that name, we actually mean runtime code analysis technology. So if you look at SAST, which is static code analysis technology, SAST looks at the code itself, right? We take the source code, we give it to the SAST engine, it reads it, it tries to interpret how it would run. With runtime code analysis, what we do is we actually analyze the code in memory. So we plug into the application a little bit like a debugger, and we look at how it's running, step-by-step execution in memory. And I'll talk more about that. And the main thing that it gives us, it lets us do an analysis of what the code is actually running like, right? The actually executed code, unlike static analysis where we try to guess what it does. And we can see exactly what's happening. We can see all the memory manipulation. We can see how queries are generated. We can see how files are being accessed, everything in runtime as it happens. And it can also provide us visibility to the data that goes through the system. So not all IAST do that, but with IAST technology, we can look at the actual data that goes through the system, look at the data repositories. Now the name interactive, which is why Gartner named it like that, because you'd say RAST may be a better name, right? Runtime application security testing. So the name interactive comes from the fact that with this analysis, it's very easy to create an interactive testing. So you see what's happening in the runtime, and based on that, you can create the next test or request to send, and it's an interactive process. So HTTP requests and responses feed attacks or requests or behaviors they want to see, and then the runtime analysis engine can look at them and see how they take place in the code. So let's look at, sorry. Let's look at a basic IAST architecture. So we have a web server and a database. This is very much not the real world, right? In the real world, we have more complicated applications, but we'll talk about that later. We have a web server and a database. The web server is running some code, storing data on the database. For now, we assume no stored procedures. Very simple, single-tier application. So the IAST solution is basically consisted of two parts. There is an agent that sits on the application server and a console that generates HTTP traffic. In some of the IAST solutions out there, they work together. In some, this console can be independent. But there must be something that generates HTTP requests because we analyze the running code. So the code has to run, and it needs to get HTTP requests for that. Now, the IAST console would normally tell the agent, I'm about to start sending requests. You have to start monitoring, and we'll talk about what this monitoring can be. And we'll then send an HTTP request. The application at this point is processing the request like it would normally do, right? It's completely transparent. The process doesn't feel that it's being monitored. But this agent is looking at everything that's going on. And for instance, if this application is sending some ODBC call, the agent's able to see that, right? Because it's part of what the process is doing. It can track that. And eventually, the application finishes running. At this point, the agent collects all the information that it collected from the runtime, sends it back to the IAST console, which can then process that, maybe correlate that with the response, right? If it's a SQL injection, I don't really care about the response. Everything's happening at the back end. If it's a cross-site scripting, the response obviously has something to do with that because it's a response-based attack. So what can I do with this monitoring? What can I monitor? And the simple answer is everything, because I'm on the process, I'm running there. But if you want to get some more practical examples, so I can see the HTTP request coming in, going out. I can see it being processed, taken apart into parameters. I can see the parameters themselves propagate through the application. So let's say you send some request that says A equals 2. And then there's some function that takes this 2 and puts it into an array. And then it's taken out from an array and putting it into another string or another integer. It's possible to track all that things because you track all the calls, all the string manipulation calls, all the array creations, everything that goes through them. Of course, I can see the HTTP response writing. So if we're looking at vulnerabilities like cross-site scripting, anything with writing back to the client side, we can see it being written at the server level. Database calls, directory calls, file system calls, basically anything. And also, we can see everything that goes to third-party libraries. So runtime analysis is not analyzing the source code. It's analyzing the binary. So if you have third-party libraries which run as part of your application, they are also being analyzed. Even if we have code which is automatically generated, like some of the modern frameworks that generate code on the fly, that also can be monitored. And we can also identify all the calls to external applications, APIs going out to third parties, and so on. So you can monitor anything. Now, how is this working? How do we monitor that? So there are a lot of ways to do IAST implementation. The most popular one is instrumentation. If you don't know, how many people here know what instrumentation is? Okay, for those who don't, instrumentation is an API provided by many languages, well, runtime environments, not all of them, common in Java, .NET, and so on, which is originally designed for performance. It lets you inject code in runtime that runs before or after lines of code of the original application. You can use it to collect timestamps and so on. That was the original purpose. But with instrumentation, we can inject into the process memory code that monitors the things we want for security. You can only do that, and it does not require us to have the source code. It does not require us to modify the binary. So the binary remains the same. It's being modified in memory, but it's not affecting the system on the persistent file. But there are other ways to do it. So you can do it with debugging. You can connect through debugging interface, and even if you don't have instrumentation in some technology, you can always do it through debugging, because debuggers give us everything, right? I can break after every line of code. I can look at the memory, I can put watches, I can do anything I want. Some theoretical discussions are talking about doing it by modifying the actual runtime environment, right? If I'm Oracle, if I'm Sun, I can say, okay, here's Java. I add some feature that will let me get information on everything that's going on there. So it's possible. I haven't seen yet in real implementation. I have seen some stuff with aspect-oriented programming, so it modifies the code during compile. But these things with aspect and recode, recompile, they're already less transparent. They modify the code. So there's this open source basic IAST taint tracking solution on PHP, but it's actually changing the PHP file. It's inserting lines of code and then removing them. But if something crashes in the middle, well, your PHP file is no longer the same. So what can be monitored? Anything can be monitored, but it's easier with platforms like .NET, Java, PHP, stored procedures, where we have the source code or something which is similar for the source code. So why IAST? So as I said, we get a visibility of the application. We see what it's doing. It's much more accurate than any other technology, and I'll show you later why. And as part of this accuracy, we can really eliminate false positives. So SQL injection, we see the query being changed in memory. There's no argue about that. Okay? We can also point for the source code of the vulnerability, which with static analyzers was never a problem, but for dynamic scanners, Blackbox scanners, they never show us the source code, which is always a problem if we want to let developers fix it, right? It has a high validation level, so it shows the problem. Again, when we work with developers, they don't really like security, right? They don't like us coming there and telling them what to do, and we need to get all the help that we can to convincing them there is a real problem, they have to fix it. So we get the information from the memory, it makes it much clearer to prove. And with second generation IAST and data tracking, we can identify more vulnerabilities than any other automated tool could do until now. It's also quite fast if we compare this to scanners. So scanners, usually because they don't know what's happening in the code, they have to test all vulnerabilities on all parameters, right? I take one parameter, I have to try all the LDAP injections and XPath injections and directory traversals, even though maybe this parameter is only used by a small if, which checks if it's true or false. It doesn't use it for anything. With IAST, we see what's happening in the code. We don't need to do that. And it's very, because of all this, it has a great fit for testing environment, for QA people. It's not a security people technology. It's not black box, right? Security pen testers would usually prefer scanners because they can run them black box as part of the pen test. But it's great for internal testing. So over the last 10 years, we've had a lot of solutions. I think I've seen more than 30 or 40 companies doing SAST, DAST, combination, and so on. So DAST is probably the most widely used. We have Blackbox scanners. They have one great advantage in eyes of some people, which is they can use on live applications, so you can use them in production systems. Personally, I'm not a big fan, because if you really want to test an application properly, you have to do things to it. You have to wire money, you have to buy stocks, you have to purchase items. And if you check that safe check that doesn't do any of those, you only test half of your application. But for some people, the fact that you can run it just on whatever you have online is a big advantage. The problem with scanners is they look at the response and try to guess from that how the code is behaving. It's not bad. Some of these are good, but it's usually, well, for cross-site scripting, it's great because that's the attack, the response. So we can find cross-site scripting great. But for some other things that are inside the code, it's much harder to do. We don't get the source code, as I mentioned. We don't get the memory or the data. And we have absolutely no way of what the coverage is, right? I run a scanner. Maybe the crawler found stuff. Maybe he didn't. We have no idea. With SAST, so SAST, when SAST came out, I was a big supporter of SAST when it came out. It sounds much better than DAST. It looks at the code. It gives us where in the code the problem is. But in reality, what we've seen was that SAST doesn't see how the application is actually running. It's doing a lot of heuristics around that, and better SAST solutions have better heuristics, but at the end of the day, there's a lot of, I don't want to say guesswork, but a lot of, well, try and error and trying to figure out what it's doing. And a lot of that is not accurate. So SAST is very good at finding things in the code which are not great, bad, wrong security policy, not good enough input validation, but that can overwhelm organizations, right? If you take a SAST product out of the box, usually it will find hundreds to thousands of findings, which you have to go through and find which of them pose a real threat, because their R&D will say, I'm not going to fix 5,000 things, right? They're not as accurate in finding the real vulnerabilities that are exploitable and can be used by hackers. They also have a lot of difficulty. We've seen this last year with some of the new frameworks which generate code on the fly, because they don't see the code. It's generated on the fly. So over the last few years, we've seen that, and actually Gartner was a big supporter of that, of doing SAST and DAST correlation, which sounds great, because we try to take the best of both worlds, right? We try to test the running application, we try to look at the code, we try to correlate them, and it is better. I mean, and again, each vendor is doing it differently, but we can verify some of the issues, we can find where the problem is in the source code, because we correlate what we found with the static to the test that we ran. We've seen the first generation of static and dynamic correlation was really just run this, and then try to correlate the results. The second generation of static and dynamic correlation was more about, okay, I saw something with my scanner, so I'll tell my static analyzer to look for that, and then I saw something with my static analyzer, I'll give my scanner some instructions to focus on that. And that has been better, but we still see that at the end of the day, the results are limited. It still doesn't look at data, and I'll later talk about why data is so important. And it requires you to run multiple tools. So if before that you had a lot of problems running the static and filtering it and running the dynamic and getting it all to work, now you have to do double the effort. So over the last few years, we've been working on IAST. We're not the only one that has been working on IAST. It seems that quite some people came up with ideas in this space around the same time. I think all resulting of seeing the problems that are there. So I want to start by talking on the first generation IAST, which is more common, and it's the basic stuff. And the basic stuff, first of all, is tracking tainted input, right? Injections, cross-site scripting, things like that. I send a request, it has a parameter value, I can track that through the memory. I can see where it goes to, if it goes to a SQL statement, an XPath statement, a file command, whatever. I can see how it's being behaved. I can see the input validation in front of it. And I don't have to be 100% clear on understanding how the input validation works, because I see how it works, right? If I send a request and it's being blocked by the input validation, it's being blocked. I don't have to try and know all the different implementations, all the different libraries, like I have to do with static. It can let me show the vulnerable source code, which is very important. And just a small note on that, if you're running on environments like .NET or Java, remember, we don't analyze the source code, we analyze the runtime code. So to show the source code, you have to show a reflection of the source code. But normally with Java and .NET, the reflection is very similar to the source code. So you don't really have a problem with that. And you can see the relevant query or response or file system command or whatever it is. Another thing that we see with almost all IAST solutions is coverage. We can see the coverage, and I'll explain that in a minute. And as I said, again, where the name came from, in interactive iterative testing. So it's an ongoing process where we can test, see what's happening, right? So we saw some input validation, so we can try some other attack, some other evasion, some other technique to get around the input validation until we decide if it's good or not. So let's start with some examples. I'll start with SQL injection. You know, we always start with SQL injection. OWASP top 10 number 1. So I have a URL, okay? It's vulnerable to SQL injection, as we'll see in a second. It gets an address. Great. Here's the code behind that. Now that's the code as, it's a reflection of the code. That's the code as an IAST solution can take out. Okay, so it's from this method. Here's the code. Now, the point is that we've seen the code, but the detection itself is done by seeing how this code creates a query, right? So we have this query, right? Text plus and plus address like plus p address. We see it's a dynamic query, right? And we see it being used here. Now, we don't see the whole code. Maybe there's some input validation before, maybe not. But what we can see is that under normal conditions, right, when we recorded this application and a user uses it, this is the query that is being generated. And we can see that we run the attack now. And we call this URL now with this query. And we can see that this query was generated. Why? Because when the IAST solution runs, it sees that this text is being created as a query. It looks at the value of this SQL string in the memory just a minute before it goes to the database. And it can tell you, look, normally it looks like this. Under attack, it looks like this. There's a clear validation and verification for the SQL injection. Now, had I have input validation on something, I would not have reached this point, right? Because the input validation would kill my code execution, right? If I have the word union break, then I would not have gotten to this point. I would not have been able to see the injection. Maybe I would have tried something else. But in any case. Yes?
Is it the case that if you have, I guess, a debug version, maybe the PDBs or something on a Windows box, that you, or whatever the according files would be, that you could almost tie it to a line number for developers to?
Yeah, you could tie it to a line number. I can say that we did it in the beginning and we stopped doing it after we got all kinds of systems where we were provided code that did not match the actual binaries, and then we would provide the wrong line numbers. So technically speaking, it can be done. It's not a problem. So reflected cross-site scripting, again, the same concept. With reflected cross-site scripting, of course, I can do a black box-like testing because I see the response coming out. But I really want to see it being in the code. So again, you can see it actually being written here, right? This label account ID text equals this. And when this is being run, we see this being written outside. I have a really good story about that. We had a customer a while ago. We came to do a POC. We're running it. We found 7 cross-site scriptings in their app. It's like, guys, you got a lot of cross-site scripting. I said, we know. They said, what do you mean you know? Aren't you fixing it? Like, yeah, we know. We had a pen test half a year ago. Yeah, that's a cruel reality, right? I've had stuff I found and it took 2 years to fix. Anyway, we've had a pen test half a year ago, and we showed it our developers. They claim it's not their problem because we are based on some third-party infrastructure, which I won't mention at this point. And they claim it's the vendor's problem. And the vendor says, no way, we don't have this problem. It's the code you wrote on top of that has this problem. And they've been arguing and bickering for 6 months, and we still have cross-site scripting. So we ran this, and we could see exactly where the code is. By the way, 5 vendor, 2 customer. 2 of the problems were in the customer code, 5 in the vendor code. We're now talking to the vendor. But anyway, so it's really, really important to see where in the code the problem is, right? Now, coverage. I think everybody who's been involved in automatic testing, whether it's application security automatic testing or just QA, knows that coverage is one of the most important and difficult things to deal with. And especially with security. I could test 90% of your application with no vulnerabilities, but you have a huge SQL injection in the remaining 10%, we're not getting anywhere. So one of the things that you can do with IAST is monitor coverage. And actually, I think everybody who's playing in this field is doing that. And if you look at that, so when you take the binary, you do a basic static analysis of it, and you extract what's the code that's running it. And then as you run, you can literally paint every line of code that's being executed, right? And then let's say I get to this if is admin. So this part's not going to run. So I can see that, and I can say, look, this has been tested, and this has not. And coverage is not about URLs or parameters. It's about code.
Yes.
It's not designed for production. It's a test. It can run overnight, although it doesn't, because the number of requests are not that high. But it's not a production solution. I think, realistically speaking, if it's a timing-based race condition and not an inherent race condition like a synchronous 2 pages race condition, there are very few automatic solutions or manual solutions that pick that up other than by chance.
Oh yeah, that wasn't a criticism.
So I agree that in some cases, but it's not very bad. I mean, the overhead's it's not running 10 times slower, okay? So it's running 20 to 50% slower normally, so it's not, it really depends. With instrumentation, it's much better than with debugging, because with debugging, you actually stop the process, and that really influences timing, whereas with instrumentation, you're more streamlining into the process. You're slowing it, but you're not inherently changing what's going on.
So it's kind of like you're using a half-speed CPU or something of that effect.
Yeah. So when we look at the coverage, right, and that's a big thing. People from the scanning board, when they talk about coverage, they talk about having all the URLs and having all the parameters, but it's really about seeing which code flows are actually running. So with this, we can actually see exactly which part of the code was tested and which not. We can also improve that, right? So I can see that there's a problem here. Maybe I can create another request that will run as, okay, in this case it's admin, so it would be a little harder. But if the if parameter value is 4 and not 5, it runs a different piece of code, I can run another request that will generate that part. And in any case, I can give you metrics at the end of the test and tell you, look, this is tested, this is not tested, right? You need to get that covered as well. Well, that's, you have to implement the logic of the testing. So at the end of the day, you have to have, I mean, like any other product, like scanners parse the results and static analyzer parse the code. But what we do, again, we instrument to begin with what we want to see. So we don't take all the data, but just what we are expecting to see. And from that, of course, we still get a lot of data, especially with coverage, because with coverage, you get a line, a record for every line of code that was executed, but you just use it and throw it away. For input tracking, you just track, for instance, string manipulations on the strings that you send. So it's easier to do that. But there's a lot of data for sure. And
But it's easy to tell the tool what to track.
yeah. But again, that's the technology. The user doesn't have to do it. It's all built in the logic of the analysis. So that was the basics. Now let's talk about the more advanced things that you can do with IAST, because taint tracking is great, but it's still not giving us the whole picture. So for us, second generation IAST means 2 things. The most important is data tracking, and as a result, we get a lot of things, which is end-to-end tracking. So an application is not just one server. Usually there's a front end, back end, some data repositories, maybe some calls to third parties. And as a hacker, I'm attacking the application. I'm not attacking just this part of the code or that part of the code. Also, I'm not just attacking one URL at a time, right? Maybe I have some process in my application, a wizard. So with second generation IAST, we can take advantage of tracking data and looking at all those things. So we can correlate different codes, different parts of code segments, like in end-tier applications or all kinds of asynchronous operations, and I'll give examples in a minute. We can classify what data is going on, because we see everything in the application, but we also replay user behavior. So we can say this data belongs to this user, and this data belongs to that user. And now with this knowledge, we can start testing for permission issues, authorization, authentication, what people in our industry like to call logical vulnerabilities, like parameter tampering and flow bypassing and things like that. And we can see how data is handled by the system, which lets us check a lot of things that we want to check, and normally a lot of automated tools are not that great at. So let's look at a real-world architecture, right? That's how an application would more likely look. We have a web application, we have some backend working with web services, we have a database, it has some stored procedures. And now in that configuration, you need to get the agent on each of these components, right? Because each component is doing part of the application logic, and we need to test everything. So when we start running on that, right, I send in monitoring for the first server, okay? Send the request, same as before, but now this application is calling a backend through a web service. So at this point, the agent says, wait, stop. It actually stops the call and says, okay, let's turn on the agent on the backend. And it tells the agent on the backend, you're going to get some requests. I've already processed it this far. Now you continue from where I stopped. Okay? And then this is run on this server. Now maybe it calls some stored procedures. Now stored procedures, it's just another application layer, right? It's not a database anymore. We like to call it the database, but stored procedures are running on an application container in the database. So we need to analyze that too. So we say, wait, so let's analyze that. And then all of this is correlated together to look at how a single user request is going through the entire application. And we need that because we want to track the data. If somebody put his credit card here, right, and it went here and here and here, I want to see that. Because maybe here, it's not being stored encrypted. And by looking at this code, I will never know that, right? Because this code is not storing it. It's the code here on the stored procedure that's storing it. So we have to look at all that. Now another thing, and for me that's always been very, so I've done pen testing for many years. I've had my own pen testing company. And for me, one of the things that were always important is, again, looking at the business logic, looking at what the application does. So if I have something like add to cart, checkout, pay, right? That's a logical process. I have to test it together. I can't just go directly to the payment page and try to test it, right? It's not even going to work. The code's not going to run because there's nothing in the cart. But if we look at it, right, I have an add to cart, XYZ, right? XYZ is stored here in the session. I get an OK. I have a second page, which is checkout, which gives me an order ID now, which comes back to the user, well, the web page of the user, right? And then I have the pay, where I send the order ID and the payment information, right, my credit card information. Only at this point, this request takes place, right? And at this point, the XYZ that I put here goes into the database. If I want to test this for a SQL injection even, I have to add to cart with XYZ quote, checkout, pay. If I don't do the whole process, not going to see that, right? So we have to look at applications together. So I want to give a really simple example of something that we can do with IAST around that, and that's persistent cross-site scripting. So with persistent cross-site scripting, we have two pages that are independent, and together they have a vulnerability. Now I think everybody here should agree that persistent cross-site scripting is a lot worse for the customer than reflected, right? With reflected, I need to send you a link and you need to click it, and then I can just do phishing and, you know. But with persistent, it's a real serious attack. And the only way to test it is to find the correlation between these two pages. So if we look at that, let's say I have a wire, I send a comment in that wire, right? I'm wiring you some money for the car. You write it in English. You can maybe put a script there. It goes to the database and stored here, right? That's maybe how it looks, some query. right? Here I put it. And then, a few days later, another page which is completely unrelated to the other page from a technical perspective, right? It has a different URL, maybe it doesn't even have a link from that page, is accessing that data and gets that information out. And it's being attacked, right? I have the script and I have to do this correlation to find that. And that correlation is based on this red thing, on the comment. Because the only thing in which is the same for both of these pages is the data they work on. So data tracking is really, really important. Now we can do a lot of other things with data. Have a few more minutes for some more examples. Yes?
So then this would be a good tool to find things like second order SQL injection as well then?
Yes. So CSRF, another case where we want to look at data, right? CSRF is like a really simple vulnerability. It has to be a link that has no random data in it that was a result of a previous request and does something, right? What does something mean? So some scanners say that does something is that it's in a post, but that's assuming the developer wrote it like they were supposed to do, and we know that's never happening, otherwise we would all be out of job. So does something means usually that it changes something in the data, some persistent data change. Add something, remove something, change something. So with data tracking, it's very easy to look. See, I see that this request, which had no random data, and I could guess it, changed this data. Set allow third-party wires true, right? That was the query that did that. Another example why data is important. So I mentioned that before. Logical vulnerabilities, parameter tampering, right? It's the easiest vulnerability in the world. I go, I change a value of parameter to some other user's record, and I see that data. Now, to do that, we need to know that these are records of users. We need to know that this record belongs to one user and that record belongs to another user, and we need to be able to do that. So, right, so I get this is the URL. This is a record that belongs to user A because we got it through user A. But when you run, you can map and say, look, I'm looking at the data, I'm running both users on the system, and I can tell you, these are the records that belong to user A. These are the records that belong to user B. And now I can do the test. After I have all this information, I can come in, I can log in as user B and try to access the data that belongs to user A. And of course, I can see that the query here doesn't have any validation. And as I track the data going out, right, I did the query, I got the data, it's being sent back in the HTTP response, I can also make sure that there is no validation on the way out. Right? Sometimes I've seen that happen. Sometimes the query itself would extract the data without validation, but then before it goes to the response it's being written. So by tracking the whole thing, you can make sure that there is nothing preventing this attack from happening. My last example, tracking sensitive data. So we have data which we define as sensitive data. Credit card information, passwords, PII, anything else you want to define as sensitive. And you want to track the data, right? So one of the last projects I did before we sold our pen testing company was some very large e-commerce site where we found a log file which the developer used to write the credit card number, including CVV, billing, all the information, just a second before they sent it out to the transaction component, because they had some bugs there and it didn't work. So they put it in a log file. They forgot to take it out. There were about 3 million credit cards there when we got it with CVVs. It was great. Some were expired, but you know, we can make do with that. So when I know. So when with tracking data, you can see all that. You can see each piece of data that you want to flag as sensitive in runtime where it goes to. Does it go to a file system? Does it go to a database? Is it being sent to some third party in HTTP? Okay? Is it sent back to the user in clear text? Anything like that, you can see it. And it doesn't have to be based on heuristics or guessing or seeing if you have some annotations in the code that say that it's sensitive data. Just see the data running through the application. So, in summary, I hope I managed to show you a little bit of what IAST is. I have a lot more examples, but time is always limiting in these events. So IAST, runtime analysis of application, where we can see everything that's happening inside the application, inside the code, in memory, and all the data that is being used by the application. I always personally had a problem with differentiating SQL injection from blind SQL injection, because blind is just a technique or a situation of SQL injection. And I've seen some scanners that gives it SQL injection or blind SQL injection. It's the same problem. As far as IAST is concerned, there's nothing, it's the same, because the SQL injection occurs at the creation of the dynamic query, and you see it happening, and you don't care if there's a response or an error or anything that goes back to the user. That's just hacker technique. It's not a problem in the code. Again, it depends on the tool, but it should be quite simple, because you don't need, because you see the actual code running, you don't need to do a lot of customization on the rules and the logic and things like that. I would say it's more testing-centric, but through the development lifecycle, yes, because I think personally I'm a big believer that application vulnerabilities are just another quality issue. It's a bug like any other bug, and it should be something that this empowers development to do that. If it's an external team, a lot of times we would prefer the black box because they don't need to get the agents deployed. But it's an external team. They bring the reports, and then the R&D ignores them. That's right. That's the reality we see. Thank you very much.